Hello friends, myself Dr. Avinash Paudhe from Adarsh Mahavidyalaya Hingoli. As we have seen in the previous video, the five-membered heterocyclic compound furan, its molecular orbital picture, the physical properties, resonance structure and general electrophilic substitution reaction. In this video about the furan, we are going to learn its synthesis, some of its electrophilic substitution reaction, reduction reaction and Diels-Alder reaction. First, we will see how the furan is synthesized from mucic acid. Distillation of mucic acid under dry condition first gives furic acid. Distillation of this mucic acid, this is mucic acid containing 2 carboxylic group and 4 OH group. On dry distillation first gives this furic acid. Furic acid is nothing but alpha carboxylic furan, and this furic acid on heating at its boiling point undergo decarboxylation. Simply this CO2 eliminates to form the furan. This is simple synthesis from mucic acid. Mucic acid on dry distillation first gives rise to furic acid, which on heating undergo decarboxylation to form furan. This is the first method of synthesis of furan from mucic acid. Now the second method from succinaldehyde. Succinaldehyde heating with dehydrating agent like P2O5 or H2SO4 or ZnCl2 undergo dehydration to form furan. This is succinaldehyde. When it's heating with either P2O5, ZnCl2 or H2SO4, it undergoes dehydration to form furan. This is tautomerized form of the furan for succinaldehyde. Simply this OH and OH, one H2 molecule eliminates to form furan. Simple dehydration of succinaldehyde, enol form of the succinaldehyde in the presence of P2O5 or H2SO4 or ZnCl2 gives rise to furan. Simple dehydrating the succinaldehyde, you will get the furan. These are the two methods of preparation of furan. First from mucic acid on dry distillation followed by decarboxylation gives furan. Second, succinaldehyde on dehydration using P2O5 or ZnCl2 gives rise to furan. These are the two methods of preparation. Now we will see the electrophilic substitution. As in our previous video we have seen why the electrophilic attack takes place at 2 position. We will revise here as we are studying some of the electrophilic substitution reaction in this video of furan. As we know that furan is nothing but oxygen containing 5-membered ring. It contains 4 carbon atoms. Out of these 4 carbon atoms, 2 sets of equivalent carbons are there. Carbon number 2 and 5 means the carbon which are attached to oxygen are equivalent to each other, and the carbon number 3 and 4 which are not attached to oxygen, this and this 3 and 4 are equivalent. Means there are 2 different kinds of carbon number 2 and carbon number 3 or carbon number 4 and 5. This carbon number 2 and 3, if the electrophile has to attack, where should be it orient, either 2 or 3. As we have seen, there are 2 possibilities. If the attack takes place at 2 position, then intermediate carbocation form, which is stabilized by these 3 resonating structures. If the electrophile attack at 3 position, then the formed intermediate carbocation is stabilized by 2 resonating structures. As we know that any structure or compound have more the resonating structures, more will be its stability. As the intermediate carbocation, which is formed by attack at C2, carbon number 2 are having 3 resonating structure as compared to carbocation which is formed by attack at 3, which are having only 2 resonating structures. Hence the intermediate carbocation which is formed by after attacking at 2 position is more stable than the intermediate carbocation which is formed after attack at C3. That's why, as it gives more stable structure after attacking at carbon number 2, the incoming electrophile prefers to go or attack at carbon number 2 in case of furan. That's why electrophilic substitution reaction takes place at carbon number 2. This is general electrophilic substitution reaction. Any electrophilic generating reagent generates electrophile, formed generation of this electrophile. As we seen, it attacks at 2 position. After attack at 2 position, one of the pi electron with this carbon atom 2 will form a bond between incoming electrophile. As this carbon loses pi electron, it acquires positive charge. Hence, carbon number 3 acquires positive charge, carbocation, and these pi electrons, which are conjugated to each other, there will be possibility of stabilization. As you know that pi electron or lone pair of electron, when they are conjugation with any positive charge, negative charge, or lone pair of electron, they will have a resonance, possibility of resonance. As this pi electron, when shift towards this carbocation, the carbocation gains electron, becomes neutral, but this carbon number 5 loses these pi electrons and becomes positive charge. Again, this lone pair of electron and positive charge are conjugated, separated by sigma single bond. This pi electron shift towards this carbocation, it gains electron, any positive charge present, then gains electron, becomes neutral. Any neutral atom which loses electrons, oxygen loses this pair of electron, loses electron, becomes positive. Hence, in this way, there are 3 resonating structures are formed after attacking at 2 position. These resonating structures finally undergo deprotonation by any nucleophilic reagent or nucleophile in the reagent. This proton is abstracted, proton is except this pair of electron, bonded pair of electron. This pair of electron will shift towards carbocation. This carbocation gains electrons and becomes neutral. In this way, 2 substituted product is formed. This is general electrophilic substitution reaction of furan. Now we'll see some of the electrophilic substitution reaction, that is nitration. As we know that for nitration, concentrated HNO3 or nitrating mixture of H2SO4 and HNO3 is used. But in this case, furan, if we use this such kind of nitrating mixture, the furan undergoes polymerization. That's why instead of nitration, it undergoes polymerization. That's why the nitration of furan takes place in presence of acetic anhydride and HNO3. It will use the 2-nitrofuran. Hence, furan, when react with HNO3 and acetic anhydride, it undergo nitration. That is, NO2 group is the electrophile, will attack at 2 position and give rise to the product 2-nitrofuran. This is nitration of furan. We couldn't use the, or we cannot use the usual nitrating mixture H2SO4 and HNO3 or simply HNO3. It will undergo polymerization. That's why we use HNO3 in presence of acetic anhydride. It will use 2-nitrofuran. In this case, it is a electrophilic substitution reaction. The electrophile substituted attaches NO2, nitronium ion. Now the sulfonation. Sulfonation of furan is carried out by passing SO3 gas. SO3 gas itself is a electron deficient. As we see the resonating structure of sulfur trioxide, the central sulfur atom is acquiring a positive charge because it is attached to more electronegative oxygen. Hence, it acts as a electron deficient electrophile. Hence, that's why the sulfonation is carried out by passing SO3 gas in position of pyridine, and it will give rise to 2-sulfonic acid, furan 2-sulfonic acid product. That is, SO3H group will be attached to 2 position. Halogenation. The direct bromination of furan in presence of dioxane gives 2-bromofuran as a major product. Simpler bromine, when react with furan in presence of dioxane, it undergoes bromination. As the halogenation is electrophilic substitution reaction, one of the bromine positive charge will attack or substitute at 2 position to form 2-bromofuran. Simpler, the bromination are carried out in presence of dioxane by reacting with bromine gas. Now the Friedel-Crafts acylation. As you know that critical of acylene take place in presence of Lewis acids and acetic anhydride or acetyl chloride. When furan will react with acetic anhydride or acetyl chloride in presence of any Lewis base, in this case SnCl2, it will give rise to the acylation takes place at 2 position, that is addition of CH3CO takes place at 2 position to form 2-acetyl furan. Simple critical of acylation reaction by using acylating agent acetic anhydride or acetyl chloride in presence of Lewis base to form a 2-acetyl furan. Gattermann-Koch reaction. Furan reacts with carbon monoxide and HCl in presence of Lewis acid AlCl3 gives 2-formyl furan, which is called furfural. Simple reaction when furan react with carbon monoxide and HCl in presence of Lewis acid, it undergo formylation, and the formylation takes place at 2 position to form 2-formyl furan, which is called furfural. This reaction is called as Gattermann-Koch reaction. Gomberg's reaction. When furan heated or treated with phenyl diazonium chloride salt in presence of NaOH, it gives 2-phenyl furan with the evolution of nitrogen gas. This diazotized salt when react with furan in presence of base, it undergo coupling to form 2-phenyl furan. Reaction with N-butyl lithium. As we know that N-butyl lithium is a kind of organolithium compound, which is examples of organometallic compounds, as there is a direct bond between metal, that is lithium, and carbon. As carbon is more electronegative than lithium, it generates a nucleophile alkyl group having nucleophile. In this case, lithium is having positive charge. That's why the lithium, as being a electrophile, attached to 2 position and forms 2-lithium furan. Means when furan react with N-butyl lithium, it will give rise to 2-lithium furan and with butane as a side product. These are the different electrophilic substitution reactions of furan which takes place at 2 position to form particular product. Now the reduction of furan. Furan can be reduced by passing hydrogen gas in presence of Raney-nickel to form tetrahydrofuran. Simple reduction. Furan will react with hydrogen and Raney-nickel. All the 2 pi bonds are hydrogenated to form tetrahydrofuran. Now the Diels-Alder reaction of furan. As you know that Diels-Alder reaction is the addition reaction of diene and dienophile to form a cyclic structure. In this case, the furan, as it is a less aromatic as compared to other 5-member heterosexual compounds like pyrrole and thiopine, because oxygen in this case is more electronegative than nitrogen in case of pyrrole and sulfur in case of thiopine. As it is more electronegative, it abstracts the pi electron cloud towards itself, and that's why there is a less delocalization of the particle and it is a less aromatic. As it is less aromatic, these 2 pi bonds are act as a dienophile. Hence the furan undergo Diels-Alder reaction. For example, when furan react with this dienophile malic anhydride, it undergo Diels-Alder reaction, addition reaction, simple addition reaction to form this adduct product, and the reaction is called Diels-Alder reaction. This is all about the electrophilic substitution reaction, reduction and Diels-Alder reaction of furan. Thank you.